So in this question, I'm asked to shade the region D union E dash. There are two conditions. I must be in D. That's the first condition. The second condition is to not be in E. Because they're being combined with the union symbol, I know that I will shade any region which satisfies either of those conditions. So this outer region over here satisfies the condition that it's not in E. This one over here satisfies both conditions, because it's in D and it's not in E. Over here, this one fails the condition that it's not in E, but it passes the condition that it's in D. As long as I pass either one, I'm fine. This is the only region that fails, because it's neither in D or not in E. So that one wouldn't get shaded. So my shading would once again be the whole Venn diagram, apart from that little crescent shape over there. So another question where we're having to feed numbers from sets into a Venn diagram. My universal set is all the numbers from 21 to 30, and I have some sets defined by rules, and the very first thing that I would do is write out the lists of elements for those sets. So I'm looking for multiples of 3 from that universal set. So I've got 21, 24, 27, and 30. Now I'm looking for prime numbers from this set. Remember what I said in the previous video, these questions will often test your knowledge of things like prime numbers, square numbers, multiples, and factors. So the first prime number that I'm seeing in the universal set is 23. After that, the next prime number I'm seeing is 29. Don't be tempted just because a number is odd to assume it's a prime number. Think about your times tables. You can also use prime number decomposition on your calculator to test a number. Let's say, for instance, that you thought 27 was a prime number. Now, of course, it's in the 3 times table, the 9 times table, so hopefully we wouldn't make that mistake, but let's say in this question you did. In order to test if 27 is prime using your calculator, you're going to type in 27 and press the equals key to store it in the calculator. There is then a key which I've mentioned before, which is the time key. But above the time key, you should see the word fact. So if I press Shift and then that key, it's going to give me the prime factors of 27. So if I type in 27, press equals, Shift and that time key, it's going to actually break it up into its prime factors, and the calculator will tell me that is 3 cubed. If I were to try this with the number 29, all I would get is 29. So this is not prime because it's 3 cubed, and this is because it doesn't factorize into prime numbers. Note that if you have a newer calculator, they have removed this feature for some reason, so you'll just have to rely upon your times tables skills. Let's have a look at set C. X such that x is less than or equal to 25. If you struggle to tell the difference between less than signs and greater than signs, it's actually very easy. Here's a less than sign and here's a greater than sign. The less than sign looks distinctly like the letter L for less. The greater than sign definitely doesn't. So the one that looks like a letter L is a less than sign. I'm after all the numbers which are less than or equal to 25 from the universal set. That's 21, 22, 23, 24, and 25. So now that I've done that, I'm going to return to my universal set and take them term by term and find the best fit for them. So the number 21 is the first one we have to deal with. This appears in set A and C, but not in set B. This area over here is the area that's shared between A and C, but not by B. So my number 21 would go here. 22 appears only in set C, and this is the part of set C that belongs only to set C. 23 is in B and C, but it's not in A. 24 is in A and C, but it's not in B. 25 is only in set C. and 26 is in none of these sets, so it goes on the outside. 27 is only in set A. 28 is in none of these sets. 29 is only in set B. And 30 is only in set A. So we can see that A and B don't actually share any elements at all on the Venn diagram, and if we check our lists for our elements, we can see that makes sense. So it's now asking me to use set notation to complete these statements. 26 something set B. 26 does not belong to set B. Now in set theory, the symbol for belongs is this little E symbol over here. And to say does not belong, we would put a cross through it. This thing over here is asking me what A intersect B equals. Now, A intersect B is the crossover between sets A and B, and we can see there's nothing in there. That category is empty, and in set theory, the symbol for empty is this one over here. There's nothing there. Now I'm asked to list the elements that satisfy this set of conditions. I'm going to break it into two. Condition number 1 is that we must be in B. Condition number 2 is that we are in C and A. In both C and A. Those two conditions are being combined with the union symbol. The union symbol says if I satisfy either condition, I win. Now on this Venn diagram there are quite a few regions to look at. There is 1, 2, 3, 4, 5, 6, 7, 8 regions to look at. First of all, I'm going to look at my first condition, because I get to look at anything which satisfies either one of these conditions. So elements which are in B. Well, B is these 4 areas over here, so I'm going to get to use 29 and I'm going to get to use 23 because they're both in B. The other condition is that I must be in both C and A. Now this area over here is everything that's in C and A, and 21 and 24 live in there. So I get to list all the elements which satisfy either the condition that they're in B, which is the 29 and the 23, or in the other condition, they must be both C and A. That's the 21 and 24. So my list would be 29, 23, 21, and 24. I'm also asked to find NC. Now, C, of course, contains the elements 21, 24, 23, 25, and 22. But this little n over here asks me for how many numbers, how many elements. So I don't want to list these numbers, I want to see how many numbers are contained. 1, 2, 3, 4, 5. So NC is 5 because C contains 5 numbers. Now this condition over here, I'm going to jot that down at the top so I can go back to my Venn diagram. B dash union B intersect C. I want to find the number of elements that satisfy that condition. So let's unpack that condition for a second. The first part of it, over here, says it must not be in B. The second condition says I must be both B and C. And I get to look at elements which satisfy either of those conditions. Sorry, we're getting a couple of glitches here. Which satisfy either of those conditions because of the use of the union symbol in between them. So I'm interested in elements which are not in B. Well, that's the 27, the 30, 21, 24, 22, 25, 28 and 26. Don't forget about those out there. But they can also be in both B and C. So there's an element which I didn't get to count before, which is the 23, which satisfies the second condition. I get to use elements which satisfy either one of these conditions. So I'm getting to use the 27, the 30, the 21, the 24, the 22, the 25, the 28, the 26, because they satisfy the first condition. And I get to use the 23, because that satisfies the second condition. Once again, we're not being asked to list these numbers, we are being asked for the number of elements, because of this little n symbol over here. We're being asked for the number of elements that satisfy that condition. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 elements satisfy that condition. So this question is full of important vocabulary for set theory. Make sure that you take that on board and remember it when you're going into an exam. Oh, look, there's more. A intersect C is a subset of A union C. Complete this statement using set notation. One more bit of vocabulary. To say subset, we use a less than symbol. Remember, we can tell a less than symbol because it looks a bit like the letter L. But because it's set theory, because we're talking about a subset, we soften it. Our set theory notation is full of nice soft curves, so we make our less than symbol into a soft curve as well. So there it is. So, having just gone over what that symbol means, this is the subset symbol again. We want to write down a subset of Q. P is a subset of Q, and a subset simply means it uses the same elements, no more. So I could make lots of different sets for P. I could just say P equals the set with just the number 1 in it, because that's fully contained within the set Q. I could make P into 1, 2, 3, 4, 5, or 3, 4, 5, or 2, 6, or whatever I wanted. As long as I'm simply recycling elements from Q, then I'm making a subset. Let's have a look at this shading question. I get to shade anything which satisfies either the condition that we are in M, or the condition that we're not in N. Seeing as I get to shade regions which satisfy either one of these conditions, I'll take them one at a time this time. So regions which satisfy I'm in M are these two over here. Regions that satisfy not being in N, well, that's this one again, and also the outside. So once again, I'm shading everything apart from that crescent shape for N. Next one looks more complicated. The first condition is that I'm in A or B. A or B. That's the first condition, and the second condition is that I'm not in C. These two conditions, A or B, the second condition that I'm not in C, are being combined with the intersection symbol, which means in order to shade that region I must satisfy both conditions. Now, let's think about the fact that there are 8 regions to consider here. I can just go through them region by region, as I've shown before, and put ticks or crosses, but I'm going to be a little bit more targeted now. Let's look at the first condition, that I'm in A or B. The only areas of this Venn diagram that satisfy that condition are these ones over here. Okay? Everything in here is in A or B. And remember in maths, or includes both, so I get to do these as well. However, I must also satisfy the condition that I'm not in C. So these 6 areas that I've looked at over here have to be put through the second test, which is that I'm not in C. That leaves me with these 3 regions over here. These get discarded because they're in C, and so my shading would just be in these areas over there. So I can go through the whole Venn diagram as I've shown before, but as we start to get more confident, we can be a little bit more selective, a little bit more targeted. So now we're getting towards the end of the worksheet. We've got another one where we have to complete a Venn diagram. Now my universal set is given in terms of a rule, so I'm going to want to make a list for that to start with. X is an integer means whole number, between 60 and 70. Whenever we see inequalities arranged like this, we always think between. X is between 60 and 70. This is true visually, as well as with the mathematical meaning. We are not allowed to include 60 and 70 because they haven't used or equal to signs. So I'm looking at 61, 62, 63, 64, 65, 66, 67, 68, and 69. Now E, F, and G, I'm going to make lists for those based on the numbers in the universal set. Odd numbers from this set, 61, 63, 65, 67, and 69. Prime numbers from this set. Wow, that's quite difficult. Remember what I told you before about the prime numbers test? If you think a number is prime, and of course all the odd numbers might come across as candidates for being prime numbers, you want to type it into your calculator and use that prime number decomposition. Once again, let's say I'm testing 61 to be a prime number. I'll key in 61, press equals, press shift, and then press that time key with the word fact above it. If I type in 61 equals shift and that time key, it just comes straight out again as 61. That's telling me it's a prime number. But if I did the same thing for 63, it would actually split it up. If I do the same thing for 63, I'm getting that it's 3 squared times 7. So that's not prime. So 63 wouldn't be included. Now any number ending in 5 can't be a prime number unless of course it's 5 itself. It must be in the 5 times table, so I'm not going to test 65. 67 is also prime, and 69 is not prime, it's a multiple of 3. If you have one of the newer calculators without this key, then I hope you have good times table skills. Now I need square numbers from the universal set. Notice that, by the way, I didn't even think about testing my even numbers from the universal set because they obviously divide by 2. They can't be prime. Square numbers from the universal set, the only square number contained in there is 8 squared is 64. So this is quite difficult in terms of testing your numeracy and your vocabulary of inequalities and integers and all the rest of it. Now we must complete the Venn diagram below to show this information. Starting with 61, they've already done that for me. And by the way, if you were confused about where 61 should go, you could actually interpret that from the Venn diagram. 62 does not appear in any of E, F, and G, so it lives out here. 63 appears only in E. 64 appears only in G. 65 appears only in E. 66 in none of them. 67 is only in, oh no, it's in F and in E. So 67 is in E and F, but it's not in G. 68 is in none of them. 69 is only in E. And that's all of my numbers accounted for. I now want to find the number of elements that satisfy the condition given in here. We can be in E or F or not in G. So I get to satisfy any of those conditions. Let's take them one at a time. Elements which satisfy that they are in E, that's the 63, 65, 69, 61, and 67. They all satisfy the first condition. Also in F, well, there's nothing in F I haven't accounted for. Or not in G. Everything I've already ticked is not in G, but I also now get to tick the 62, 66, and 68. Remember, the union symbol means I can satisfy any of these conditions or only one of them. So the only one of these numbers that doesn't satisfy this condition is 64, the number that's only in G. Little n asks for the number of elements that satisfy it, so I don't make a list. I count up how many numbers I've got. 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers satisfy that condition. Use set notation to complete the statement E intersect F intersect G equals. So I'm looking for numbers which are in E and at the same time in F and at the same time in G. In other words, numbers that would exist in this middle section of the Venn diagram here. It's empty. And our symbol for the empty set is this one. So that concludes the solutions for the set theory and Venn diagrams worksheet.